compound of this kind, OHSOCl. Well, this H plus going out, this coming here, this going above, going down, and Cl minus going out, would be how you'll be getting sulfur dioxide and HCl. Okay? On the chlorine, not required. This Cl minus being more free is going to do that. All right. So this is how generally we convert an acid to a halide. We convert an acid to a halide, and we're able to carry out different transacyl reactions. The most popular of them being esterification. So maybe a quick thought about a few facts with esterification. As most of us know, esterification would be about converting acid alcohol to an ester in water. Certainly going to be a reversible process. All the reactions, transacyl reactions, will be eventually reversible. And things like the following, God knows how many times you have seen before. RCOOR prime plus water and if this O is O18, by labeling this oxygen I am able to prove that effectively it's this oxygen which is incorporated into this molecule. To some extent I am able to deduce the mechanism, because if I am labeling the alcohol by oxygen O18 and I am finding it completely incorporated in the ester, this means that certainly this lone pair over this oxygen is acting as the nucleophile. Yes or no? And a quick thought could be this acting as a nucleophile, this going above, this coming down, and OH minus going out. This oxygen getting a positive charge, releasing it by losing H plus, OH minus and H plus forming water, could be a general approach, a general thought about how esterification is going on. I told you it's reversible. The forward process is called esterification. The hydration of ester is called saponification. Reversible process carried out both under acidic or alkaline conditions. Under acidic conditions it's called Fischer esterification. Given an opportunity and if required, we might go into a very detailed understanding of how the simple looking mechanism could have further diversifications depending upon the nature of the acid and the alcohol, but that we'll want to do only if if we have some extra time or only if that's required. In general, this could be the perception acid alcohol forming ester water, because O18 of the alcohol is getting incorporated, staying with the ester, that oxygen is acting as the nucleophile. All right. Well, hydrolysis of ester, I told you this is a reversible process, could be carried out under both acidic and basic conditions. Hydrolysis of an ester, RCOOR prime plus water, forming RCOOH and R prime OH, again would be like writing the previous reaction in a reverse order. Will again be catalyzed both by an acid or a base, will be catalyzed both by an acid or a base. What needs to be understood is, if I am carrying out hydration of an ester, if I am carrying out hydrolysis, alcohol hydrolysis, there is a difference between hydration and hydrolysis. In hydrolysis, I'll see the molecule breaking. So certainly it's getting broken into an acid part and an alcohol part. So it's hydrolysis of ester. Under acidic conditions, I'll get an acid and alcohol. But certainly under alkaline conditions, instead of the acid, I'll get RCOO minus. I'll get RCOO minus. Where? Because the carboxylate is stabilized by resonance. Because the carboxylate is stabilized by resonance. So realize, for it to happen either way, for it to move forward and backward, and depending upon our requirement, whether we are willing to carry out an esterification or we're trying to obtain an acid and an alcohol from an ester, we want the reaction to move forward or backward. Some common principles which can never go wrong are, suppose a process of this kind, esterification, and you want it to move forward. You'll want to add a lot of acid and alcohol. Law of mass action, basic rules of equilibria. Reactant बढ़ाओगे, the equilibrium will move to the right. If you want the reverse to happen, you'll want excess of water. You'll add excess of water and you'll have hydrolysis carried out. And if you have excess of acid or alcohol added, you'll have esterification going to a larger extent. Both forward and backward, it's acid or base catalyzed. I can tell you about different kind of mechanisms involved. I told you if time permits. In general, I want to convey a very important piece of information to you with the simple representation and with the understanding that for this to move forward, if this oxygen has to act as a lone pair in the catalyzed or uncatalyzed form, and to move it back, if this oxygen has to act as the nucleophile, certainly if it's about hydrolysis of ester, I already told you a lot of water is going to help it move forward. A lot of acid and alcohol would have done the reverse. Don't you think? But it's moving forward and backward because you're able to identify the nucleophile and the carbon which is going to be attacked in either cases, which is the same carbon eventually. One way of controlling the yield would be by understanding that in acidic and basic condition, because the acid form has two different forms, and when you look at this form and this form, you realize that this form, the carboxylate, is stabilized by resonance. It's stabilized by equivalent resonance, not only resonance, equivalent resonance, where you know that we have spoken about a uniform distribution of electron density, a very effective resonance, and if it's very effective resonance, stabilizing it considerably. The reactivity of this carbon, because of equivalent resonating structures, the reactivity of this carbon or the nucleophilicity over this carbon, you could say the positive charge eventually over this carbon, is very diluted, because of very effective resonance, And first of all, I wanted to buy that under acidic conditions, while hydrolysis of ester is carried out, here you'll get the acid. Under alkaline conditions, you'll get the carboxylate. There should be no doubt over that. And when you look at the two forms of the product under acidic or basic conditions, because you realize that the carboxylate is going to be inert to a nucleophilic attack. It will be inert to a nucleophilic attack. This carbon will be almost inert to nucleophilic attack because the carboxylate is fairly stabilized by equivalent resonating structure. Certainly carrying out hydrolysis under alkaline condition would be like curbing the backward reaction, and you would want to recall that alkaline hydrolysis of ester is kind of irreversible. A very popular statement which could be conveyed, which could be understood by this basic fact, that in acidic medium you're going to get the acid in this form, under alkaline medium you'll get the acid in the carboxylate form. And all reactions, forward, backward, they're all reversible. Both acid and base catalyzed. But because this is almost inert to a nucleophilic attack, when you're carrying out hydrolysis of ester under alkaline medium, you're kind of curbing the possibility of backward reaction, which is esterification here. And given a choice, you'll want to carry out hydrolysis under alkaline conditions. So acidic hydrolysis might well be reversible. Acidic esterification might well be reversible, but alkaline hydrolysis of ester will be irreversible. Alkaline hydrolysis of ester will be irreversible. Fair enough? So keep this in mind, and some small little facts about other reactions of acid we'll learn in course of solving some problems. See, I'm not looking at teaching you things which you have already seen, in the sense I'm not going to repeat decarboxylation for you. I'm not going to repeat some other reactions which you have seen for acid. You've seen it getting reduced to an aldehyde and then to an alcohol. So because we know about all those reactions, we'll want to see some general unique characteristic acids. Physical properties, again, you know, they're going to be soluble in water because of hydrogen bonding. Aromatic acid, benzoic acid, is going to be presented to you in a problem as a white crystalline solid. And more of the chemical properties we'll want to learn while solving some problems. So have a look, let me know if you have a doubt somewhere, and a problem sheet will be given to you. Start attempting.